Hello, this is Mr. Precella. I'm back for continuing working on the review sheet for our third exam in my face-to-face trigonometry class. And we're up to solving equations. Number 25 says, solve this equation over the interval 0 to 2 pi. And you're doing this without using a calculator. All of these are wind up with special angles. And hopefully you either have that unit circle memorized, or I'll give you a blank one if you want to fill it in real quickly for the test. But there's no way around having this unit circle memorized. Either be able to see it in your head or jot it down. Okay. Number 25 says tangent x minus 1 times cosine x plus 1 equals 0. Well, here the equation on the left is factored, so it's a product. The only way we can have two things multiply together to give 0 is if at least one of those things is 0. Okay? Either the tangent x minus 1 is 0 or the cosine x plus 1 is 0. No way around that. So on number 25, just set each one of those factors to 0. If tangent x minus 1 equals 0, or cosine x plus 1 equals 0. Solve this for x. So we have tangent x equals 1, and when I say solve for x, at this point I'm solving for one of the trig functions. Now to solve for x, look at the unit circle. We're looking from 0 to 2 pi. Remember what this interval notation means. It means include 0, but don't include 2 pi. So if your answer occurs here, write 0, don't write 2 pi. So let's see, where's tangent equal to 1? Well, tangent would be 1 right here at, how are these angles written, answers written? Radians? Okay. Pi over 4, if you go sine over cosine, that would give you a 1. And also down here in quadrant 3, sine over cosine, negative over negative would give you a 1. So at pi over 4 and 5 pi over 4, and what about cosine x equals negative 1? Well, only place on the unit circle that cosine is negative 1 is right here at pi. So what are our answers? Pi over 4, 5 pi over 4, and pi. Well, that is, where are they listed? Here, A. On the next one, number 26, looks like it's not already factored for you. So we better do a little factoring on this one. Key problem solving strategy. If you know how to do one type of problem, here it is factored with a 0. We know how to do that. So here on number 26, let's factor it and have a 0 on one side. Well, how can I factor it? Well, looks like there's a cosine x in each term. If I factor a cosine x from each term, what's going to be in the parentheses? If I factor out a cosine x, well, all that's left here on the first term is just a 1 minus, is it 2 sine x equals 0. Now once it's factored with a 0 like that, set each one of the factors to 0. So we set the cosine x minus 1 to, the cosine x equals 0. And then the 1 minus 2 sine x equals 0. This factor is already ready to look at the unit circle. The trig function's by itself. Here we need to get the sine x by itself. So I'll subtract 1. And then divide by negative 2 to get sine x equals positive 1/2. So to get the purple answer, I look at the unit circle. Where is cosine equal to, where's cosine x 0? Okay, so where's cosine 0? Cosine is 0 at pi over 2 and at 3 pi over 2. Where's sine equal to 1/2? Sine is 1/2 here at pi over 6, and also in quadrant 2, 5 pi over 6. So pi over 6, 5 pi over 6. Once again, where's cosine x equal to 0? At pi over 2 and 3 pi over 2. Remember, these ordered pairs are in the form cosine comma sine. Where's sine 1/2? Well, at pi over 6 and also at 5 pi over 6. So let me look at these answer choices. They may not necessarily be written in the order. It's probably written, let's see, an increase in order, pi over 6, pi over 2, 5 pi over 6, 3 pi over 2. So this one's C. Number 27, solve this equation on the interval 0 to 2 pi. Let me rewrite this problem, color coding it some. So we're looking at number 27. Sine x plus 3 pi over 4, pink plus, just to help keep straight everything, sine x minus 3 pi over 4 equals 1. Well, I'm going to have to expand this. That sine x plus 3 pi over 4, you can't just distribute the sin. Do y'all remember how to expand something like this? Use the sum formula. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. For sine, it starts with sine, so sine, cosine, same symbol, cosine, sine. So this green stuff is where I've expanded the sine x plus 3 pi over 4. Sine, cosine, cosine, sine, same symbol in the middle. The next plus I'm about to write down is this one right there. And now I'm about to use that same expanding formula. Sine, cosine, same symbol, cosine, sine, equals 1. So sine, cosine, cosine, sine, same symbol in the middle that's in the parentheses there, okay? Now let's see what happens. Does something subtract out right off? The cosine x sine 3 pi over 4 minus cosine x sine 3 pi over 4. Those subtract. The sine x cosine 3 pi over 4 plus sine x cosine 3 pi over 4. We can go ahead and add those together and write them as 2 sine x cosine 3 pi over 4 equals 1. Now, this cosine 3 pi over 4, that's a number. We can look at the unit circle and see that cosine 3 pi over 4 is negative square root of 2 over 2. So I'm about to replace the cosine 3 pi over 4 with the negative 2 square root of 2 over 2. In fact, I'm thinking of it like this. Multiplication is commutative, so It doesn't matter if I write the cosine and then the sine or what, but I'm thinking of it like that. Now I'm about to replace this cosine 3 pi over 4 with the negative square root of 2 over 2. And here, this 2 and that 2 cancel. So we have negative square root of 2 sine x equals 1. Get the trig function by itself, so divide both sides by negative square root of 2. I'm wondering if y'all are at the point where you can rationalize this in your head. If you see 1 over square root of 2, hopefully at this point you know that's square root of 2 over 2. So I'm now ready to look at the unit circle. Where on the unit circle does sine equal negative square root of 2 over 2? Well, nowhere up here, because all these sine values in quadrant 1 and 2 are positive. It's going to be down here. 5 pi over 4, sine is negative square root of 2 over 2, and also it's 7 pi over 4. 5 pi over 4 and 7 pi over 4. So this is number 27. 5 pi over 4 and 7 pi over 4, that is B. Now, it's 27. Now let's do number 28. It's another one like this. Let's see if I can color code it. Cosine x plus 3 pi over 4 minus cosine x minus 3 pi over 4 equals 1. Okay, so I'll expand this one right here. That's cosine, change, sine, cosine, change, sine, or cosine, sine, change the symbol in the middle, minus, let's see, cosine, I'm now going to use that same expansion, cosine, change, sine. What I've written right there isn't really right. This pink minus applies to all of that. Let me put that in parentheses. What am I trying to say we're going to have to do with that? Well, we're going to need to distribute that minus sign there. Let me see. I'm going to distribute this minus. So it would go here. And then that's going to change this minus right here to a plus. Let me see. Oh, I didn't change. Cosine, change. Okay, there. Okay, I knew there was something wrong. Cosine, change, sine. Now once I distribute that minus, it's going to change this plus to a minus also. So let's see, the cosine x, cosine 3 pi over 4s, those are subtracting out. Ooh. We have negative sine x, sine 3 pi over 4, minus sine x 3 pi over 4. That's going to be a negative 2 sine x, sine 3 pi over 4 equals 1. Now, I'm going to go ahead and look up sine 3 pi over 4. And if you prefer, we can rewrite it so that the sine 3 pi over 4 is right by the negative 2. Wow, this one I think is going to work out similar to the other one. Sine 3 pi over 4, 3 pi over 4, the sine value square root of 2 over 2. Sine x equals 1. So these 2's cancel. So we have negative square root of 2 sine x equals 1. Divide both sides by negative square root of 2. So we have sine x equals negative 1 over the square root of 2. Well, you get to rationalize that again. Multiply above and below by square root of 2. And we have negative square root of 2 over 2. So where's sine negative square root of 2 over 2? Not up here. Down here at 5 pi over 4 and 7 pi over 4. Just like the other one. Oh wow. Don't decide, oh well, I'll just always guess 5 pi over 4 and 7 pi over 4. They certainly don't always work out like that one. But I think on both of these it just so happened on 27 and 28 they're both 5 pi over 4 and 7 pi over 4. Now, what about number 29? Let's do another sheet of paper. Let's see, number 29, I'll color code it. Cosine x plus 5 pi over 3 plus cosine x minus 5 pi over 3 equals 1. Expanding this one, cosine, change, sine, cosine, sine, change the symbol in the middle, plus, let's see if I can do this without messing up on the other one. Remember, I didn't change the sign. Cosine, change, sine, So let's see what's going to subtract out here. Well, the sines are the ones subtracting out. We have cosine 5 pi over 3 plus cosine 5 pi over 3. So 1 cosine blah blah plus 1 cosine blah blah is 2 cosine x cosine 5 pi over 3 equals 1. So let's look up cosine 5 pi over 3 on the unit circle. As the reference angle pi over 3, the cosine there is 1/2. So we have 2 times 1/2 times cosine x equals 1. Oh wow, this works out really nicely. The 2's cancel. We have cosine x equals 1. Where on the unit circle is cosine equal to 1? Only one place, at 0. And then again at 2 pi, but it only wants us to write our answers over the interval 0 to 2 pi. Include 0, don't include 2 pi. So here, x is 0. It's D. We're almost through with these. Let's see. One more. Number 30. Well, I'm going to write this in blue. And I'll write this one in purple. So I'm expanding this first. So that's the sine expansion. Sine, cosine, same symbol, cosine, sine, sine, cosine, cosine, sine, same symbol in the middle, then minus, that's this minus right here. Now, expanding sine x minus 11 pi over 6, sine, cosine, same symbol, cosine, sine. Now since there's this minus sign here, we gotta be sure to distribute that black minus there. Okay, but I've expanded sine x minus 11 pi over 6. Sine, cosine, cosine, sine, same symbol in the middle. Once I distribute this minus, I'm the sine minus. So these are subtracting out. Sine x, cosine 11 pi over 6 minus sine x, cosine 11 pi over 6. And when I distribute this black minus over here to this one, it's going to become a plus. So we're going to wind up with 2 cosine x sine 11 pi over 6 equals 1. We'll go ahead and rewrite it. 2. I'm going to write the sine 11 pi over 6 in color, or in blue. Cosine x equals 1. Okay, sine 11 pi over 6. That's this angle right here, which has the pi over 6 reference angle. So sine, there's a negative 1/2. So I have the red 2, a blue negative 1/2. Cosine x equals 1. 2's cancel, so we still have a negative 1. Cosine x equals 1. Divide by negative 1 to get cosine x equals negative 1. So where is cosine negative 1? There's only one place. Right here at pi. Okay? That would be C. And that does it for this review sheet for the third test. This is in my face-to-face trigonometry class. Okay, so work on this stuff and master it. You should be able to do all of this stuff without having to be punching into your calculator. For inverse trig functions and solving equations, you should have this unit circle memorized, period. You should already have it memorized. You should have memorized it at the time of the first test. So happy studying and good luck on the test. Thank you.